Access to real estate and business listings is a completely commoditized, solved problem. Any investor with an internet connection can pull exactly the same inventory from public listing sites. Millions of raw data points, permit filings, and unverified seller claims flood the market daily. This sheer volume of unstructured information actively paralyzes human operators during the underwriting process, making thorough analysis impossible at scale. The true bottleneck is architectural. Operators rely on reactive software tools that sit idle, only analyzing specific documents when a human manually triggers a request. Scaling deal flow requires moving from these sequential, user-triggered pipelines to persistent, autonomous agentic loops. An agentic loop operates continuously in the background. It monitors market variables, simulates future financial outcomes, and executes complex analytical tasks entirely without human prompting. We are going to deconstruct the specific AI framework that enables this proactive architecture, detailing how it performs predictive deal underwriting at an institutional scale. Mastering this continuous, loop-based architecture is the only way a solo operator can replicate the decision velocity of a large-scale investment fund. Advanced underwriting does not begin by browsing available properties. It requires establishing specific personal life outcomes and rigid financial timelines first. An initial intake agent collects abstract user variables, like risk tolerance and total available capital. It translates those inputs into a strict, mathematically structured portfolio recipe. In the deal engineering phase, operators stress test this generated recipe. They apply different creative financing structures to see how the mathematical model holds up under various debt loads. This diagram shows a standard acquisition capital stack: SBA loan, seller notes, and equity. Adjusting the seller note directly impacts the live debt service coverage ratio calculation. If the debt structure fails this DSCR threshold, the property is unviable and analysis stops. Defining strict mathematical boundaries up front ensures the autonomous system only deploys compute power on highly qualified targets. The primary technical barrier to scaling continuous AI analysis is computational expense. Specifically, the high token cost generated by large language models, AI systems trained on massive datasets to process complex text, when they execute deep, multi-layered underwriting tasks. Traditional architectures assign a single massive model to every task. This wastes expensive compute power on simple extraction or basic formatting operations. To solve this, the system uses a dynamic router. This heuristic algorithm inspects the specific complexity of every incoming task before deciding which model should execute it. Simple queries like data extraction route to lightweight models. Dense analytical tasks, such as stress testing a balance sheet, route strictly to primary heavy models. This per-turn routing cuts compute costs by up to 60%, preserving expensive models for heavy lifting. The second architectural pillar is trajectory memory. This is a persistent database log recording every single action an agent takes on a specific deal. Trajectory memory allows downstream specialized agents, like risk assessors, to read the upstream findings of behavioral agents. If the system already mapped the seller's urgency, the risk agent incorporates that data without performing redundant work. A central coordinator agent monitors these memory logs. It uses the accumulated context to trigger specific composable skill packs, specialized analysis modules, to assemble the final investment dossier. Pairing cheap dynamic routing with persistent trajectory memory makes continuous, autonomous deal underwriting financially viable. Relying on a single AI model to score complex financial risk introduces inherent fragility and algorithmic bias into the underwriting process. To eliminate this single point of failure, the architecture uses a dual-platform parallel simulation pattern. It feeds identical deal data into 3 distinct LLM architectures simultaneously. 3 distinct nodes analyze identical information and output individual scores. The resulting weighted average serves as the baseline consensus score. A divergence metric extracts the exact mathematical variance between the 3 models' final risk assessments, flagging uncertainty. High divergence is a critical feature, not a bug. It flags genuine edge case anomalies, unique deal characteristics that current algorithms simply cannot resolve and that require human judgment. Identifying model divergence perfectly optimizes human operator time. directing attention exclusively to deals where algorithms fundamentally disagree. Static data analysis only looks backward. The system's predictive power comes from shifting its focus to simulating human counterparty behavior. The architecture scans the raw deal file to extract subtle metadata. It isolates the specific language used in the listing, the relationship dynamics with the broker, and the business's total tenure. This visual represents the generated dossier. Extracted metadata is mapped directly to distinct psychological traits, quantifying variables like seller urgency and risk tolerance to build a comprehensive profile. The system uses this profile to spawn a simulated persona agent, a digital model representing the exact decision logic of the business owner. It then runs hundreds of rapid chat simulations against this persona, testing different deal structures using various letters of intent, formal documents that outline the preliminary commitment of an acquisition. The final output is a synthetic negotiation transcript. It details exactly how the seller is likely to counter specific due diligence asks or price reductions based on their simulated psychology. Simulating the seller transforms the operator's posture. You move from reactive negotiation into fully rehearsed execution. Predicting a single counterparty is the micro level. Expanding that scope allows the system to model an entire local market ecosystem. Complex, highly emergent behaviors naturally arise when hundreds of completely independent entities interact continuously within a closed environment. This concept is applied through swarm intelligence. The system populates a digital environment with hundreds of independent, memory-equipped persona agents, representing local buyers, brokers, and municipal actors. The simulation begins with a trigger sequence. The digital environment is seeded with a real-world market catalyst, such as a major zoning change or the approval of a new infrastructure permit. As the catalyst pin drops, surrounding nodes process the variable and form dense clusters. Interacting over a simulated 90-day timeline, agents make decisions based on programmed memories. The system tracks these interactions to mathematically flag the highest probability future transactions in the market. Simulating human reactions to market catalysts allows the system to identify actionable deals weeks before they ever appear on a public listing site. The autonomous pipeline operates in distinct stages. It translates goals into strict recipes, dynamically routes computational power for efficiency, and measures baseline risk through consensus divergence. By simulating both individual counterparties and macro-level market swarms, the system generates deep predictive intelligence prior to any capital deployment. The result is a closed-loop system functioning continuously, identifying and structuring opportunities entirely without the need for manual human intervention. This proactive architecture bypasses the inherent limitations of traditional sequential deal-finding software, which requires human labor to execute every analytical step. In modern Main Street investing, edge is no longer found in data access. It is found entirely in processing velocity. The machine handles the data aggregation, the simulation, and the financial structuring. Human judgment is strictly preserved for the final, most complex stage, acting on the fully synthesized investment dossier. Combining trajectory memory, composable analysis skills, and swarm simulation permanently elevates a solo operator to the analytical capacity of an institutional fund.